Welcome to my channel. My name is Darshan. I'm your maths prof. So in last session we saw what are the algebraic expressions and how you can add and subtract the algebraic expressions. Now in this session we'll see how you can multiply the expressions as well as how we can divide them. Okay, so let's start this. This is the fourth topic of this chapter, that is multiplication. Now multiplying the algebraic expressions, I have divided this topic into several subtopics. First is how you can multiply monomial by another monomial. Now what is monomial? Mono itself, mono means single and monomial means it's an algebraic expression with single term. Okay, so you can see here in the question that this 4xy square, it's a single term polynomial and I want to multiply it with another monomial, I mean a single term algebraic expression, that is 2x square y. So how you can multiply them? It's simple. First you multiply the coefficients, so that is 4 times 2, that is 8, and then x into x square, both are the same variables and they are in multiplication. Here we'll use the indices rule, that whenever you are multiplying variables with the same base, you can add the powers. So you can write it multiplied by x to the power 1 plus 2. Similarly this y square will be multiplied with y, so that will become y raised to 1 plus 2 or 2 plus 1, same thing. So that is 8x raised to 3 y raised to 3. Simple. It's basically applying the indices rules only, and we have already covered that topic in first chapter. If you don't know about it, just go and check out that video. It's very helpful, by the way. See the second example. Here I am multiplying three monomials with each other. So this is the first monomial, this is another monomial, and this is the third monomial. How you can multiply? First you multiply the coefficients. So let's multiply 2 with 3 and another 2. So 2 times 3 times 2, that is 12. Now this x will be multiplied with another x, because they have the same base, will add the powers. So that is x to the power 1 plus 1, and this y will be multiplied with y and it will become y raised to 1 plus 1. So that is 12 times x raised to 2 times y raised to 2. Clear? So this is how you can multiply monomial by monomial. Now let's see how you can multiply a monomial by a binomial. Now what is a binomial? Bi means 2, so binomial is an algebraic expression with two terms. Clear? So how you can multiply this monomial, which is a single term polynomial, single term algebraic expression with two terms algebraic expressions, monomial by binomial. So simply just multiply that monomial by individual term. So what I'll do, I'll multiply this 2x with a single term x, first term, and then again there is a plus sign in between, so I'll write plus, and then 2x will be multiplied with y also. Let's see. So this 2x will be multiplied with x plus this 2x is multiplied with y also. Because there is a plus sign between x and y, I put plus sign here also. Now 2x times x is nothing but 2x square, and similarly 2xy, this 2 times x times y is 2xy, and because they are not like terms, we cannot add them. Clear? Okay, so next is this 9x square multiplied with another binomial, that is 9 minus 2x. So for that, this 9x square will be multiplied with 9, and because there is a negative sign in between two terms, so I will put negative minus sign here, and then this 9x square will be multiplied with another term which is 2x. So 9x square times 9, that is 9 times 9 is 81, so it will become 81x square, minus this 9x square times 2x, that is 18 times, and x square into x is x raised to 2 plus 1. So that is 81x square minus 18x cube. Clear? So this is how you can multiply a monomial by binomial. Now let's see how you can multiply a binomial by another binomial. You now already know that what is binomial. Binomial is an algebraic expression with two terms. So you see this 2 minus a, I want to multiply it with a plus 8. It's kind of similar to the monomial multiplied with binomial only. So what I'll do, I'll divide this first binomial into two different monomials and I'll multiply each monomial with another binomial. It sounds a little bit weird, but I'll show you. It's very easy. This 2 will be multiplied with the whole binomial a plus 8. So 2 multiplied by the whole binomial a plus 8, and then negative a multiplied by the whole binomial a plus 8. So negative a multiplied by a plus 8. So now this 2 times a is 2a and 2 times 8 is 16. Then minus a times a, that is minus a square, and minus a times 8, that is minus 8a. Clear? Isn't it easy? Now this 2a and minus 8a, they are like terms. So just bring them together and simplify, and this plus 16 and minus a square will remain as it is. So this 2a minus 8a is minus 6a plus 16 and minus a square. Clear? Second, here I have written a minus 2b whole square. Now there will be another chapter of expansion when we'll discuss about this a minus 2b whole square. There is a formula for it also, but here what will I do? I'll just simplify it using this same method, this binomial multiplied by binomial. What I'll do, I'll replace this with two binomials, a minus 2a multiplied by a minus 2a, which is nothing but a minus 2b, I mean a minus 2b multiplied by a minus 2b, which is eventually a minus 2b whole square only. So it's basically 5 multiplied by 5 is 5 square. So a minus 2b multiplied by a minus 2b, that is a minus 2b whole square. Now with the same method, what I'll do, I'll multiply this a with the whole bracket a minus 2b, and this minus 2b multiplied with the whole bracket a minus 2b. So this a times a is a square, then a times minus 2b is minus 2ab. Similarly, minus 2b times a is also minus 2ab, and minus 2b times minus 2b, negative times negative is positive, so that will be positive 4b square. Now if you see this minus 2ab and minus 2ab, they are like terms, so we'll make it minus 4ab because both are negative, so they will be added. Minus 2 is minus 4, so minus 4ab and plus 4b square as it is. Clear? So this is how you can multiply a binomial with another binomial. Now in the end, let's see how you can multiply a whole polynomial. Polynomial is basically an algebraic expression with more than two terms, right? So if there are more than two terms and both the algebraic expressions are polynomial, or any one of them is polynomial and another is binomial, how you can solve it? It's the same method only, it's just that it's an extended form of that same method. So simply this 8x will be multiplied with the whole bracket. So 8x times 3x square minus 4x plus 2. Then this minus 3y. Mind one thing that I am putting this 3y with its sign also. Don't forget the sign. If it is negative, put the negative 3y. If it is positive, put the positive. Don't just bring the term without its sign. So 3x square minus 4x plus 2, and then plus 2 times 3x square minus 4x plus 2. Now let's simplify that. 8x will be multiplied with 3x square, which will be 24x cube. Now you already know I'm applying the indices rule only. X times x square is x cube. And 8x times minus 4x is minus 32x square. And 8x times 2 is 16x. Positive. And then minus 3y times positive 3x square. So that will be negative 9x square y. You can also write yx square or x square y, both are same thing because multiplication is commutative, of course. So minus 3 times 3 is minus 9. Then similarly minus 3y times minus 4x, both are negative, so it will become positive 12xy or yx, same thing. And minus 3y times 2, that is minus 6y. Similarly, this 2 will be multiplied with 3x square, and that is a positive 2, so it will be positive 6x square. Similarly, positive 2 multiplied by minus 4x, that will be minus 8x, and positive 2 multiplied by positive 2, that is positive 4. Now let's bring the like terms together. This 24x cube doesn't have any like terms, so let's put it as it is. But this minus 32x square and 6x square, both are like terms, so let's bring them together. Minus 32x square plus 6x square. Similarly, the 16x and minus 8x, they are also like terms, so let's bring them together. 16x minus 8x. And yeah, I don't think there is any other like terms, so let's put other terms as it is. Don't forget any term, sometimes if the expansion is this much large, people used to forget the terms. So this 24x cube will as it is, and minus 32x square plus 6x square, that is minus 26x square. Then 16x minus 8x is positive 8x, and other four terms will remain as it is. Clear? Yeah. Next, so that is 7xy will be multiplied with the whole 3x plus 9z. This is a polynomial multiplied by binomial, but doesn't make any difference, it's the same method only. Plus 8z multiplied by 3x plus 9z minus 2xz multiplied by 3x plus 9z. So this 7xy multiplied by 3x, it is 21x square y, applying the indices rule again. 7xy multiplied by 9z, that is 63xyz. Then plus 8z multiplied by 3x, so that is 24xz. 8z multiplied by 9z, so that is 72z square. Similarly, minus 2xz multiplied by 3x, that is minus 6x square z, and minus 2xz multiplied by 9z, that is minus 18xz square. So expansion is done, the multiplication is done. Now let's see whether you can find any like terms or not. Okay, so looking to the scenario, I can't see any like terms here. Fine, so this is your final answer. All terms are unlike terms, you cannot find any like terms here. Fine, so this is your final answer for this. Let's see how you can divide algebraic expressions. So basically you can also divide binomial by another binomial, or binomial by trinomial, or trinomial by binomial. It's already there. Basically polynomials will be divided, but here in this chapter we'll see only monomial divided by monomial, because for that binomial or any other polynomial, if you want to divide, you need to apply the formulas, apply the concept of factorization, and that is covered in, I think, other chapter, I think 6th chapter or maybe, or 5th chapter, so we'll see that later. Right now here we'll only see the monomial divided by monomial, and that's very easy. It's just applying the indices rules basically. So let's see, the 16x square divided by 4xy, both are monomials, and what I'm doing, instead of this putting this division sign, I'm putting them in the fractional form, so that's very easy to understand. Now this 4 and 16 can be divided, because in multiplication we multiply the coefficient first. Similarly in division also we can just divide the coefficients first. So 16 divided by 4, you can cut also, and that will become 4. And this x square divided by x raised to 1, in division with the same base we subtract the powers, so that's x raised to 2 minus 1. And this y raised to minus 1, you can put it in the numerator, or you can keep the y in denominator as it is. Both are same thing. So this 4x upon y, or it can also be written as 4x y raised to minus 1. Because y is in denominator, when you shift it to numerator, the power will become negative. Simply the in indices rules you can check out in the first chapter video also, and in this playlist also I'm just pasting all those videos of the first chapter only, because as I said, in the indices there is nothing new in this chapter. The whole topic is revision from the first chapter only, in fact all the questions also, so don't worry about it. You'll have to make sure that all those questions you solve and revise it regularly, because that topic is very important. See another question. 100x square y square divided by 25x. So it's let me just put it in the fractional form. So this 100x square y square upon 25x. Now let's cut this 100 and 25. 25 ones are 25 and 25 fours are 100. So that's 4. And now in division you subtract the powers. X raised to 2 is in there in the numerator and x raised to 1 is there in the denominator. So it's x raised to 2 minus 1 and y raised to 2 will remain as it is. So this is 4 x raised to 1, so which is just x, and y raised to 2. Clear? Now I'll just give you a quick revision of this indices. As I said, I'll paste the whole topic of the indices from the first chapter only in this playlist itself. But let me give you just quick revision. I will just solve 2 or 3 questions, very simple questions of the indices, so that it will be a quick revision for you. So simplify this: x raised to 4, y raised to minus 2 whole to the power 3. Whenever in the multiplication or division there is a common power, you give them separate powers. So this x raised to 4 times 3 multiplied by y raised to minus 2's power 3 times, same thing here also, x raised to minus 2 into y cube raised to minus 2. Now power is multiplied, so that is x raised to 4 times 3 is 12 into y raised to minus 2 times 3 is minus 6 multiplied by x raised to minus 2 and y raised to minus 6. Now in multiplication with the same base we add the power, and in division of course we subtract the powers, but with the same base. So x raised to 12 plus minus 2, similarly y raised to minus 6 plus minus 6. So that's x raised to 12 plus minus 2 is 10 into y raised to minus 6 plus minus 6 is minus 12. So this can be written as x raised to 10 y raised to minus 12, or you can also write x raised to 10 upon y raised to 12, because as you already know that if you reciprocal the given base, the negative power will become positive, or if it is positive it will become negative. Okay, let's solve one equation kind of question, that 9 raised to minus x is equal to 1 upon 81. In the equation, when the power is unknown and you want to find that power, this case is the same, power is x and we want to find that x. In that case, both the sides of the equal to sign, both should have same base, and if they don't have the same base, you can convert them into the same base by doing the prime factorization. So this 9 prime factorization is just 3 raised to 2, and similarly 81, which is simply 3 raised to 4. I have shown here also. You don't need to show the prime factorization in the exam. It's just for your knowledge. You can keep this in your rough work also. So 3 raised to 2 to the power minus x is equal to 1 upon 3 raised to 4. So this is 3 raised to minus 2x, and as this 3 raised to 4 is in denominator, I'll have to first shift it in the numerator, because on the left hand side the base 3 is in the numerator. So I'll have to write it in the numerator only, so it will become 3 to the power minus 4, and both have the same basis and there is equal to sign in between, so powers must be equal. So minus 2x is equal to minus 4, minus minus got cut, 2 will go in division, so x is equal to 4 upon 2, so x is equal to 2. This is how you can solve the equation kind of questions. Here third question, it is also an equation, but the difference is here the unknown which we want to find, it is not in the powers. so that both the sides should be in the same base, and if they are not in same base, you do the prime factorization. That rule doesn't apply here. Here simply you'll have to make sure that on the left hand side where the x lies, on that side the power should be 1. Power is right now 3 by 4. To make it 1, I'll have to multiply the 3 by 4 by some other number. And simple maths rule says that if you multiply any number with its reciprocal, you'll get 1. So here the power is 3 by 4, and surprisingly the reciprocal of 3 by 4 is 4 by 3. You already know that. So x minus 1 raised to 3 by 4, what I'll do to make it 1, I'll have to multiply 3 by 4 by 4 by 3. Basically I'll have to do the powers power. And here also I'll do the same thing, because on left hand side I did the power 4 by 3, so on right hand side also I'll have to put power 4 by 3. Now this 3 by 4 times 4 by 3 is 1 only, so it become x minus 1 to the power 1, which is nothing but x minus 1 only. But here there is a number raised to power fraction. Whenever there is a fractional power to any number, you do the prime factorization of base. All these rules are made by me only. There is no hard rule for this, but please follow these rules. It will eliminate all the mistakes you make and you'll get the full marks. That's my guarantee. 2 raised to I think 6, yeah, this is 4, 2 raised to 2 and 2 raised to 1. Okay, so 2 raised to 6 power 4 by 3. So x minus 1 is equal to, now power is multiplied, so 6 times 4 by 3 is 8. So 2 raised to 8 it is, I think, yeah, 3, yeah. And 2 raised to 8 is, you can use calculator here. Of course, it's a calculator kind of question, but I already know that 2 raised to 8 is 256. And this 1 will go in addition, so it will be 257. Clear? All right. That's it for this session. We have covered all the kind of questions you can find in second chapter. Basically not all the questions, but all the topics we have covered here. For the questions, now next video will be paper 2 kind of questions, and next video will be paper 4 kind of questions. But here I'll only record the videos for algebraic expression part, because as I already told you that indices part is just repetition of the first chapter, so I'll just put that same video in this playlist. If you find these videos helpful, just give me a like and comment below this videos, and it will be very helpful and motivating for me. Thank you very much.